of two immiscible liquids, list the advantages of steam distillation, state the uses of steam distillation. We have seen how two miscible liquids can mix together to form a solution. The solution formed can be either an ideal or non-ideal solution. Let us now see what happens when nitrobenzene is added to water. Click the Add button to add nitrobenzene to water. Two distinct layers are formed as nitrobenzene and water are not soluble in one another. They are said to be immiscible. Liquids A and B are immiscible liquids. The vapor pressures of pure A and pure B are P0A and P0B respectively. The beaker on the right shows a mixture of A and B. Click on the A button to view the vapor pressure exerted by A in the mixture. Now, click on the B button to view the vapor pressure exerted by B in the mixture. Note that liquids A and B behave quite independently of each other. Each liquid exerts its own vapor pressure. What is the total vapor pressure of the mixture? Click the PT button to find out. The total saturated vapor pressure is equal to the sum of the saturated vapor pressures of the pure components. That is, PT is equal to P0A plus P0B. Let us look at the vapor pressure temperature curves for nitrobenzene, water and their mixture. Click the nitrobenzene button. Click the water button. Click the mixture button. Click 1.0 on the vertical axis. Click on the nitrobenzene curve to get the boiling point of pure nitrobenzene at 1 atmosphere. Do the same for the other two curves. The boiling point of the water-nitrobenzene mixture is lower than the boiling points of the pure liquids. Summary: immiscible liquids are liquids that are not soluble in one another. When two immiscible liquids, A and B, are mixed, they form two separate layers. Each liquid in the mixture will exert its own vapor pressure independently of each other. The total saturated vapor pressure of a mixture of two immiscible liquids is equal to the sum of the saturated vapor pressure of the pure components. That is, PT is equal to P0A plus P0B, where P0A refers to saturated vapor pressure of pure nitrobenzene. P0B refers to saturated vapor pressure of pure water. PT refers to total vapor pressure of the mixture. The boiling point of the mixture is lower than the boiling points of the pure liquids. Steam distillation is a laboratory method of separating immiscible liquids by bubbling steam into the mixture. The diagram above shows the experimental setup for steam distillation. We are now going to use steam distillation to purify nitrobenzene. Flask B contains a mixture of immiscible liquids, nitrobenzene, water, and other impurities. Click on the Bunsen burner to start heating the water in Flask A. Steam is produced from boiling water in Flask A. The steam generated is then passed into the mixture of nitrobenzene and water in Flask B. Click on Flask B. The steam heats up the mixture. It also agitates the mixture so that the nitrobenzene and water molecules rise to the surface of the mixture. Eventually, the mixture reaches its boiling point, which is below 100 degrees Celsius. The vapor formed contains both steam and nitrobenzene. The supply of steam from flask A helps to carry the vapor from flask B into the condenser. Click on the condenser. A mixture of nitrobenzene and water vapor distills over and is collected in flask C. Click on flask C to view the distillate. Flask C contains water and a separate layer of pure nitrobenzene. The nitrobenzene can be separated using a separating funnel. Steam distillation can only be used under certain conditions. Click the Conditions button. Steam distillation has several advantages. Click the Advantages button. Click the Uses button for the uses of steam distillation. Summary. Steam distillation is a laboratory method of separating immiscible liquids by bubbling steam into the mixture. The advantages of steam distillation are as follows. It is able to 1. Separate organic compounds which are heat sensitive or decompose at high temperature. 2. Remove non-volatile impurities from organic compounds. Steam distillation can be used for 1. Extracting essential oils from seeds or esters from plants, for example in the making of perfume. 2. Purifying liquids, for example nitrobenzene and phenylamine.